So again, this SOH means sine and opposite over hypotenuse. Opposite is what that says, even though my stylus is not working well. And hypotenuse. Okay? So sine, opposite, hypotenuse. This is the O, and this is the H. Okay, let's see if I can write a little more clearly for cosine. So cosine, C-O-S, cosine, is adjacent over hypotenuse. Okay. So I've got sine is the S, O is opposite, H is hypotenuse, and then cosine is the C, adjacent is the A, and hypotenuse is the H. So then this last one, TOA, is called tangent. And sine, cosine, and tangent are just 3 trig functions. They just are rules that you put in the calculator. So O is opposite and A is adjacent. Okay. And they change depending on the angle that you're talking about. So if I'm talking about angle Y, the opposite side is the 3. That's the O. Because it's in relation to angle Y. If I've got that right angle, that's the hypotenuse, always the hypotenuse. Which means the other side is the adjacent side. Adjacent is the one right next door. It's the one that's most missed. So I always find my opposite first, my hypotenuse second, and then what's left over is the adjacent. So we've got O, A, and H. And then we've got 3 different ways of putting them together. Sine is O over H. Cosine is A over H. Tangent is O over A. And that's how we get SO, CA, TOA. If we look at the triangle a different way, we look at it from the X. What's the opposite side from the X? The 4. So the O changed from the 3 to the 4. What's the hypotenuse? 5. The hypotenuse never changes. The hypotenuse is always the side across from the right angle.
Can I write this down instead and then take a picture of it and
Yeah, absolutely. Yep. And then the adjacent is the 3. It's the one left over. So when we switch between the 2 acute angles, the small and the medium angle in a right triangle, the O and the A will flip around a little bit. Okay. Does anybody need extra time on that slide? I know that was a lot of notes to kind of take down. And I'll try to post this video in the links too, so you have it as reference. Okay, let's go look at slide 6 and see if we can make some sense of it. So on the left side, these notes are for finding sides. We're going to use these starting on Tuesday. So you don't need to worry about those today. The ones we're going to use are the ones here on the right side. These are to find angles. Okay, we're going to use Desmos or some other calculator today. But first thing we need to do is identify what's the angle. So if we go from X, what's the opposite side? The 4. And what's the adjacent side? 3. And the hypotenuse? 5. Okay. So then all we're going to do is substitute those numbers in for the O, the A, and the H. So we're just going to choose one of these functions. Do we want to use sine? Do we want to use cosine? Or do we want to use tangent? We just got to choose. Let's use cosine. There should be a Pear Deck. So if you don't have the Pear Deck link, I know a couple people joined late. You can go here in Schoology. And there's the link to the Pear Deck. Okay. So we decided to use cosine. So we're going to use cosine. Cosine -1. And then what do I put in those parentheses? A over H, which is going to be 3 over 5. 3 over 5. So now I'm going to go over to Desmos. So if you have Desmos, you can open it up. If you don't have Desmos, you can just Google it. So I just Googled Desmos calculator, literally, and went down to Desmos graphing calculator and opened it up. It's also in ClassLink. So let me remind myself because I'm having an ADD moment today. Cosine -1, 3 over 5. So when you go into your calculator, you want to type in cosine -1. If you go down to the little keypad down here, they're conveniently located in functions. So cosine -1, that's the one we want. We're finding an angle. That's why we need the little -1 up there. You want to go to the wrench and make sure that you are in degree mode. If you're in radian mode, it's going to give you a weird decimal. When you get to math analysis in a couple of years, you'll definitely use radians, but in geometry, we always use degrees. So once you've got your cosine -1 and with the wrench, you've made sure you're in degree mode, we're going to put in, remind me what it was again, 4 over 5? 3 over 5. 3 over 5. And lo and behold, we've got it right here, 53 degrees. So this angle, X, is 53 degrees because that's how we went O and A and H. So if I know X is 53 degrees, that's the medium size angle. How do I find the large angle or the small angle over here for Y? What should those two angles add up to be?
It's 37.
It is 37. Thomas, how'd you get 37?
Take 180 and subtract it by 53.
180 minus 90 minus 53 gives me 37. Perfect. So I only need two sides to find one angle. And once I have that other angle, I can find the third angle, right? And it doesn't matter which trig function we use. We're going to find that out in a minute. Let's find a different side this time. So we used cosine last time, right? So let's not use that one. And we used X, so let's use Y. So do we want to use sine or tangent this time? Let's use sine, okay? So we'll do sine -1 because we're finding an angle. And we want O and H. What's the O from Y? 3. And what's the H always? 5. Huh. So we had cosine of 3 over 5 last time, and now we're going to have sine of 3 over 5 this time. Let's see what we get when we do that. It's also conveniently located here, so we can do sine and 3 over 5. So cosine of 3 over 5 gives me a different answer than sine of 3 over 5, but those two things add up to 90 degrees. So here we found this to be 37, which means this guy up here is still 53.
Did you round?
I did round. Yeah, it was like 56.8 or something like that, or 36.8. Yeah, 36.86. So I rounded to 37. But the nice thing about using this is that we can get decimals. We can get very specific, right? Yesterday, when we were just making and drawing and measuring with a protractor, we couldn't even really measure to the nearest degree. A lot of us were rounding to the nearest 5 degrees or 10 degrees. I worked for a land surveying company a couple years ago in the summer, and we measured to the 10,000th of a degree when we were measuring large plots of land. So that's 4 decimal places out, right? And we use satellites to do it, so the computers did it, but it's all used right triangles. It's pretty cool. So let's look at another one, see how well we've got this in hand. Okay, so remember I'm looking for angles. So these are sides. We're not going to use those. We're going to use those next week. We're going to use these ones over here. Do we want to go from X or from Y? Okay, let's look at X. So if we're going from X, do we want to use sine, cosine, or tangent? Have we used tangent yet? Okay, let's use tangent. See if it makes sense. So we'll use tangent. So what do I need? It is a little confusing until you get it. So opposite stands for opposite. O stands for opposite. A stands for adjacent. So I'm going to start with the X, and I'm going to go to the opposite side of the triangle. So that's the O. The hypotenuse is always across from the right angle, which leaves the 5 to be the adjacent, right? So we're going to take tangent, and right now it does not matter which one we use. When you don't have as much information, then you have to make a choice, and there's specific ones that you have to use. But opposite is 12, so that's going to go here. I'm just replacing my O. And then adjacent is 5, so I'm just replacing my A. And once you get it to this point, all you're doing is finding angle X. You put it in the calculator. So you go back to your Desmo, and we're going to put in tangent this time. Got to make sure you have that -1 when you're looking for angles. And 12 over 5. So 12 over 5. Oops, that's not what I wanted to do. And we got 67.4 degrees. 67.4. So we come back over here, and angle X is 67.4 degrees. So if I know X is 67.4, what's Y? 22.6?
Yeah.
Awesome. Okay, so basically we're starting with one angle. We're choosing a function. We're identifying the variables we need between the opposite, the hypotenuse, and the adjacent. We're sticking it in Desmos to find the angle, and then subtracting from 90 to find the other angle. Okay, we've done sine, we've done cosine, we've done tangent. What do we want to use here? Okay, let's use cosine. And let's use y, since we haven't used y. We used x last time. So which one's the adjacent to the y? 12, absolutely. So it's not the hypotenuse. It's not the opposite. It's the adjacent. So then I need the hypotenuse. So we're going to use 12. We're going to use 13. We're going to put that in our calculator. So cosine of -1 and a over h. So 12 over 13. Put that in your calculator, and what do you get? You're so fast. 22.6. And because I started at the Y, that's how we labeled the O and the H and the A. That angle is my 22.6. So how do I find X? Subtract. From what? I got 67.42. Absolutely. Yep. Because we know that the right angle here is going to take 90 degrees, the X plus the Y is going to also equal 90 degrees. Okay, every time. Let's do a couple more examples, and then we'll see if we've got this down. Okay, what am I going to ask you? Be a mind reader. Which angle do we want to use, X or Y? X. I love the definitive nature of that answer. Do we want to, what's my next question?
Which one we want to use?
Which one we want to use, or what's the adjacent, the opposite, and the hypotenuse? So let's answer both of those questions. Which function do I want to use, sine, cosine, or tangent? Sine is what I heard first. If you said tangent, use tangent and see if you get the same angle, okay?
Okay.
So we're going to use sine here, but I want somebody to do tangent. So what do I mark the 7? The O, the A, or the H? That is definitely the O. What do I mark the 25? Is that the O, the A, or the H? The H. It is always the biggest side, the H. So if I know all three sides, the biggest one is automatically the H, which leaves the 24 to be the what? The A. Perfect. So if we're going to do sine, we're going to do O over H. So sine inverse is O over H. So what's my fraction? 7 over 25. So we put that in the calculator. And if you haven't picked up your calculator yet, haven't opened Desmos, this is the time to do it. Don't let everybody else calculate for you. You definitely want to make sure you know how to do this. So what is the angle measure of X? 16.3. Did anybody else get that? So what's angle Y?
I got 15.6.
You got 15.6. Did you 7 over 25?
Yeah.
Hmm.
I did the other one.
Oh, for tangent?
Yeah.
Okay. So if we do tangent, that's going to be O over A. So that's going to be 7 over 24. So see if you change that 25 to a 24, because we need opposite over adjacent for tangent. See what you get.
It's the same thing.
Is it?
Like as the X.
Oh, okay. 16.3. Perfect. So you should be able to choose any one of these ratios. And as long as you plug in the right numbers into the formula, you should be able to get the same answer. Did anybody calculate Y yet? What's Y? 73.7? Awesome. And I think we've got the same thing here. So let's choose a different function. We've done sine and cosine of X, or sine and tangent of X. So let's do cosine of Y. So how would you set that up? So this one's adjacent. Nice. This one's hypotenuse. And it would for sure be 7 over 25. What is cosine -1, 7 over 25? which is what we got in slide 10 when we did our subtraction, right? 73.7 and 73.7. So let's go back up here. This was our 7, 24, 25. 7, 24, 25. This is the one I want to be at. So we got 73.7 degrees here. And we got 26.3. Is that right? No. 16.3. Okay. So let's see if we can do the 8, 15. What was the missing side over here in this table? Anybody remember from yesterday? What was that? 8 squared plus 15 squared equals what?
200.
And then square root that and you get, I'm hearing somebody say 17. Sweet. Decimals add to 1, so the ones have to add to 9. Double check it in your calculator. I like your mental math and I like your reasoning. Just double check it. So let's see if we draw this triangle. I've got 8, 15, 17. Do we want to use sine, cosine, or tangent? Okay, we'll use sine. Sine is O over H. So what do I put into my calculator? So if my angle is 8 and 17, absolutely. So this is the O and this is the H. So 8 over 17. And what do we get when we do sine -1 or inverse sine? 8 over 28.9? 28.1. And what's my medium angle over here? Okay. Let's try the next one. So what goes in this box? Which was what? Anybody remember from yesterday, or can we calculate it? It was 40. Okay. So we used sine before. Do we want to use cosine or tangent? Cosine. Okay. Cosine is A over H. Remember, so ka toa. So what do I put into my formula here? -1 because I'm looking for an angle. 9 over 41. 9 over 41? So this one is the adjacent if I'm using X. So 40 over 41?
Yeah.
Yep. And there's a lot of things to just a lot of little details to keep in mind here. So cosine -1, inverse cosine of 40 over 41. That is a skinny little triangle. So 12.7 is the X. So what's the Y up here, the medium angle? Nice. Let's do one more. Let's get a new color. So what's my missing number here for the 11 and 61? 60? 11, 60, 61. Let's do this angle now. Let's do the big angle, the Y. So we haven't used tangent. Let's use that. So katoa, so that's O over A. What's my O from the Y? 60, absolutely. Go through that triangle. This is the opposite side, which means what's the adjacent side?
But I'm excited to have
61 is always the hypotenuse because that's opposite the right angle. So I need adjacent over here. So inverse tangent, 60 divided by 11. This is my other angle. That is a skinny little triangle. Skinny, skinny, skinny little triangle. Try the last one on your own. Draw the triangle. What number goes in for the shortest side? 13? 15? So draw that on your own. I'm going to draw it on my own. And this is an even skinnier triangle. Decide whether you're going to find the medium angle or the skinny angle. Decide whether you're going to do sine, cosine, or tangent. And then let's see what we get. Anybody get an angle? If you get one, put it in the chat. Adjacent is the one next to the angle. So there's one of them is going to be right. So if you draw the triangle, it's a good question. So if you draw the triangle, we've got a long skinny triangle here. The short side is the 15. The longest side is the 113. The medium side is the 112, right? So then if I put my X at this tiny little sliver of a corner, that's the angle that I'm looking for. So if I go straight through the middle of the triangle to the opposite side, the 15 is the opposite. That's step number one. You have to label your opposite, your adjacent, your hypotenuse. So the opposite side is always going to be the O. Opposite from the right angle is always going to be the hypotenuse, which means the one next door to it is going to be the adjacent. Okay. Opposite and hypotenuse are both really easy to find. The adjacent sometimes is a little trickier, especially when you have a really acute triangle. Okay. So find the opposite, find the hypotenuse. The other one's the adjacent. We're looking for that skinny angle. So we're going to find this angle here first. Did we use sine, cosine, or tangent? What'd you guys use? I use sine too. What'd you get for an angle? Anybody else get 7.6? I definitely got 7.6. So let's figure out how we got that. If we use sine, right? Sine is opposite over hypotenuse. All I'm going to do is substitute in those numbers. My opposite is 15. And my hypotenuse is 113. So if you put that in the calculator, you should get 7.6. If you used cosine, which you could also do, cosine is going to be A over H. So you're going to do 112 over 113. Put that in the calculator, you should also get 7.6. As long as you put the right ratio into the function, absolutely. So tangent. And I'm not always going to give you all three pieces of information. So sometimes you've got to look at the information you have to determine the only thing that you can do. But if you do sine 15 over 113, cosine 112 over 113, or tangent 5 over 12 or 112, you should get that same 7.6 answer. All of those should be exactly the same. We're just substituting in the O, the A, and the H where they need to go. Okay, so the thing to remember, the thing to carry away with you today is so ka toa. Sine opposite hypotenuse. Sine opposite hypotenuse. Ka cosine adjacent hypotenuse. And then toa tangent opposite adjacent. Kind of your mnemonic. Okay. I know some people have got it and some people are still struggling. So I'm going to pause.